Hello everyone. So we're back again at a desk. This is a new desk. My last one was a bit small and it didn't actually have room for other things to the side. So I did have piles of stuff on top of my laptop, so I never actually used the laptop. So that's got its own space now. There's a big space in the corner and more space for all the electronic stuff. And I can even fit the whole computer project on here. So that's handy. It's still chipboard, so I get splinters from it, so I need to cover it. But yeah, it's a step in the right direction. So today I'm talking about something I'm working on for the computer project. This is not actually related to the ALU or anything I said I was going to do. This is just a different random circuit, just so I had something else to do, because I've been busy doing lots of other things. I didn't want to try and do something that was going to be a bit more difficult. So yeah, so these are D-type flip-flops, and these are to create a program counter. So just a binary counter, it goes from 0 to 15, and because there'll only be 16 bytes of memory, this will be able to point to the whole memory that I'll have. At the moment I've only got two, but they're identical, so I can just build two more of these, then we're done. Well, other than like the output register, the tri-state buffer. Yeah. So yeah, so D-type flip-flops, they both have a couple of extra pins. So these are called preset and clear. So regardless of what the current state is or what the clock is doing, you can set this to 0 or 1. Yeah, so I've got this currently tied into, so the input of this, so these brown lines, well, this line here is the clock, and this one also goes, actually no, this one doesn't go to the clock. This one goes to that clock, which is just an astable multivibrator. Its data input is its negative output, so it always toggles. And this one, its data also toggles, but it's clocked from the output of this flip-flop. So this one will work at half the frequency of that one. So you can say that this is the lowest bit. It just counts zeros and ones. This is the next bit, which counts twos. So I'll just run this, and you can see it ticking up. So you have 0, 1, 2, 3. 0, 1, 2, 3. So yeah, that's what I've been doing. And the idea is that these are all stackable, obviously, just like everything else in the project. And I need two more of these, and I'll be able to count from 0 to 15 and use that as a memory address. And then that memory address will go to the instruction register, which will actually look it up and get it out and do stuff with it. Yeah, so yeah, it's only 4 bits because I only have 16 bytes of memory, and even though I have an 8-bit bus, this will only use half the bus. So when I build the output, the tri-state buffer for this, I may have to build an 8-bit tri-state buffer, but just set half the bits to 0, just put them at ground. But yeah, that's that. Just a nice little circuit. Another thing I've been working on, if I can get it over here. So like when I'd done this I took this out in the last video, I think, when I was unpacking the post, and I've got it wired up rather badly, I have to say. Let me see if I can get it over here. So yeah, that's my solder job. I just grabbed this plug and wire from an old kettle, soldered that up. It doesn't actually use ground, just neutral and live. Neutral is ground, basically. Yeah, this can output 18 volts or 9 volts. And so if you tie the two yellow wires together, you get 18 volts. If you tie a yellow wire and a black wire together, you get 9 volts. So this is outputting 9 volts. Well, actually it's more than that, but once you give it a load, it levels out. So when I first tried this, I was actually accidentally using the wrong capacitor. So I actually have two types of, it's like a 100 microfarad capacitor now, and I have two types. This one is rated to 50 volts. The one I used was rated to 16 volts. So when I tried it on the 18 volt output, it exploded. I sort of had my ear over it at the time. Nothing shot in my ear, but it did produce a rather loud pop and made me jump out my chair. So that was fun. Yeah, I've learned my lesson. I'm going to double check my capacitors every time. The thing is, I knew I had the right capacitor. I just, I just didn't think to check that I was using the wrong one because I had the same capacity. But yeah, that's that. Nothing's actually changed on the computer project itself. It's it's still over there. I might actually try and do a thing for the ALU next because I built the inverter. I might also try and make the basically for subtraction. I just need a board with loads of XOR gates on it, and that should be enough. But yeah, I'm going to do some posts now. Like I said last week, because I only had that one thing. This week I have a lot of posts, and some of it is rather cool. See, right, I'm just checking if my address isn't on there. Doesn't seem to be, but yeah, it says charge controller for solar system there. It's not. They just put random things on there sometimes. I don't know why, but this is in little brown boxes, so I know what these are, and these are cool, right? Don't know which one's which. Right, here we go. So what this is, well, this one's an amp meter. Amp meter. So these are going to be on the front panel, and they'll show me how much power the computer is currently using. And the other one in here is a voltmeter, which will show me how many volts the power supply is putting out. Just because I want a dial, I just want some nice dials on it. And yeah, so I couldn't go with digital ones because this is a discrete build. I can't have integrated circuits. So I got these analog ones, which I believe they have no circuits exactly. They're just wires. They're just wrapped around and similar to a transformer. It's just wire wrapped, and it produces a little magnetic field which drags this. Yeah. So yeah, these are quite small. They should fit on the front panel quite comfortably. Let me get the other one out. Oh, yeah, just not just throw that over my shoulder. Now I can. And yeah, this is the voltmeter, which goes to 15 volts. I'm either gonna I'll have two lines. I will have 12. It'll go up to a max of 12 volts because it's going to have other stuff in here which will run at 12 volts. But most of it will be 5 volts. I wonder if I can give this a quick test. I'm not going to test the amp meter because that's a little more tricky to set up. Just give me some wires. Give me some wires here. Have I got any male-to-male wires? Yeah, I didn't. No, I won't bother testing it. I'll stick it to the front panel at some point and test it that way. I just haven't got the wires sitting around at the moment. Or have I? What's that? No, that's a male female. I hate DuPont cables, and whenever you need the right one, you've all got you haven't got it. You've got all the other ones. But yeah, these are analog, so they're not integrated circuits. They're just coils, as far as I can tell. Either way, they're not critical to the actual function of the computer. So even if I made a mistake and there's like a little chip in there or something, it's not the end of the world. They're not digital either way. Let's get those out as well. It's that way round. Right. Oh, okay. So I've got a couple things here. So these. Right. Let me just open them and go through them because. Oh. I assume that's the invoice. Right, so which ones are these? So the idea here was to buy some big power transistors. Not linear regulators, because regulators are integrated circuits, but power transistors are just transistors, they're just big and chunky and have a big plate on it so you can fix a heatsink. These ones, God, I can't see that, it's really difficult. Let's take it out of the packet. Okay, so this is a TIP 120, which I don't think is a transistor. I think that is it's a variable linear regulator, I believe. So yeah, I was looking for, I have an idea of what I want to do for the discrete regulator. And I was looking at, there's different values of these, and some of them they're linear regulators, some of them are power transistors. So I ordered them first because they were in an open tab, and I was like, I'll just get those ones. And then it turns out that they're the wrong things. But I didn't cancel the order. Didn't think it was worth it. It's not a unique code, I don't think. So yeah, these ones, yeah, these are TIP31Cs. These are power transistors, I believe. So yeah, no integrated circuitry going on here, just a big ass transistor. So yeah, those will be to build a linear regulator from components, discrete components. And one more thing, actually I might need space for this one because it's, yeah, quite chunky. Have to open this old school. Oof. So that is okay. This is a sheet of perspex, and it's green transparent perspex. So yeah, you can see through it. So I got this for the front panel at the moment. So you know how I have the 7-segment displays? They're green. So I got some transparent, or dark transparent green perspex. So it was at this. I don't think I ordered A4. I really don't think I ordered A4. But yeah. I thought I ordered a smaller size because there was, what is it, or maybe I did, A5, I don't know. I know the higher you go, the smaller it gets, doesn't it? So yeah, I think getting one, I think the options was you can get one A4 sheet or 5 A5 sheets, and I thought A5 would be better because it's closer to the actual size I need. Actually, A5 is the equivalent of 4 of these next to each other, right? But it turned out you can actually get more out of just buying one A4 sheet. Because what is A5? A5 is like, I don't know, it's like a quarter of that, I think. Oh no, it's actually like that. A5 is like that. I can't remember. I'll have to double check what I ordered because I didn't think it was A4. But yeah, I don't mind. Yeah, it just turned out cheaper when I was calculating the sizes. But yeah, so that'll probably go on next week. Let's just peel a little bit off the corner here so you can see it. Yeah, there's another sheet on that side as well, so you can't really see it. But I'll leave that on until I put it on the actual computer. But yeah, that will just do the one panel at the moment. I'm not sure if I'll have other panels that are cut out like that and have green LEDs behind them. But I'll use this for other projects. I've got a few ideas for weird projects I could do with just these little boards, just like one little board, little circuit in there with some green LEDs to show a picture or some text, and just screw little perspex panel on the front of it. So I don't know, it's just quite a nice visual thing. Nothing actually useful, just a nice visual. But yeah, that's everything today. I'm excited to get all these fitted on. So yeah, next week might be another front panel video with just loads of bits added to it, or maybe a power supply update. Who knows? I'll probably try and show you the power supply working next week because it does work and it doesn't explode anymore. But yeah, thank you for watching, and I'll see you next week.